Hi, welcome to Kailasha Foundation classroom. Today in this video I am going to explain the Claisen condensation reaction and its mechanism, like how Claisen condensation reactions takes place. So so first we will see that what a Claisen condensation reaction is. So in Claisen condensation reaction actually uh, uh, two ester reacts to form a ester enolate, or let me write, and after the ester enolate ultimately the formation of a beta keto ester. So the reaction looks like R CH2 bond C double bond O bond OR dash. This is a general ester, and in the presence of NaOR dash. See here we do not use NaOH, instead of we are using NaOR dash. Why I will explain later. Mm, Then the first will be form an ester enolate. Here we will see C double bond H, C bond CH. And here will be the negative charge bond C double bond O bond O. This will be a ester enolate, and then ultimately again the same ester molecule RCH2 bond C double bond O bond OR dash. This will take over here and CH2 bond C double bond O bond CHR, this CHR bond C double bond O bond OR dash plus OR dash minus. And this is what a beta keto ester. Now let me make you familiar with the terms here, alpha and beta. We know that the alpha carbon is right next to the functional group. So here our functional group is ester and this is our functional group. So right next carbon here, this will be the alpha carbon here. And we know that alpha carbon is acidic. In case of ester, alpha carbon is acidic in nature. So and here again the main functional group is here ester. This is this ester, and so this will be your alpha carbon, this will be your beta carbon. The second carbon will be beta carbon, and the first carbon nearby the main functional group is alpha carbon. Why we call it a beta keto? Because at beta carbon there is a keto group, so we call the ultimate product as a beta keto ester. So let's take a look at the mechanism of this reaction, like how the reaction proceeds and how the product forms. One more thing I want to tell you in this, that the notice the product which is actually an original ester with an acyl group added, that is here the acylation reaction has occurred, that is this is actually a nucleophilic acyl substitution reaction. Now here in this product, this sorry, let me try it again. Let me change the color so that it will be easy for you to understand. This portion, this portion is your acyl group, and this is your original ester. Sorry that my writing is a bit difficult to understand, or I do not write good, but I think I am able to explain what I'm trying to explain. So this is your original ester and this is the acyl group. So you can see that this is nothing but the acyl group substitution in the original ester, or this is a nucleophilic acyl substitution where the formation of the product is what we call a beta keto ester. So let's move ahead for the reaction mechanism. In the mechanism of Claisen condensation, three steps occurred. In the step 1, the step 1 an acid-base reactions takes place. Acid-base reaction takes place. Here the alkoxide functions as a base and removes the acidic alpha hydrogen, giving the reactive ester enolate. Listen my words, that the alkoxide functions as a base. What is our alkoxide? Alkoxide is our, from this NaOR we can get RO minus. This is our alkoxide. So this removes the alpha hydrogen, giving the reactive ester. Now this is in basic in nature. So what it do is, just suppose this is our ester bond CH2 bond H. Why I am showing not CH3 and writing CH2H, because I want to show you that this will be your alpha carbon. See, this is ester, so this will be your alpha carbon, and this will be acidic in nature. This is a base, so simply acid base reactions will take place, and this will remove the alpha carbon, and this bond will break, and the product form will be, in the first step, the product form will be R bond O bond double bond C bond double bond O bond CH2. Okay, because the electron of this bond are migrated towards this carbon, and this hydrogen is removed by this alkoxide, and the rest will be this ROH. Simple. So this is what the first step is. Now in the second step, the nucleophilic ester enolate. This is our ester enolate. So the nucleophilic ester enolate attacks on the carbonyl carbon of the another ester. Now obviously this will be present in the, so another ester will be here, our in the step 2. In the step 2, the ester enolate will attack nucleophilically over the carbonyl carbon of the another ester. So another ester will be again this double bond O bond CH2 CH3, and this will attack here. This is our carbonyl carbon. So what will happen? The product will be bond O bond double bond O bond CH2 bond this bond O bond CH3 bond OR. You can see here the attack will take place, and this bond, the transfer, this double bond will break, and see here I have drawn this nucleophile here. So this is what your nucleophilic attack of R double bond O bond C double bond O bond CH2, and this attacks here. So this bond breaks, and here carbon will have 6 electrons around, sorry, oxygen will have 6 electrons around it, and this OR group is there, and this CH3. Now what will happen, and this is an intermediate. So in the final step, in the step 3, intermediate finally collapses and reforming the carbon oxygen double bond, resulting in the loss of the leaving group, which is what our alkoxide ion. So what will happen actually is that this will come here and this will break. So the product is, final product is come from this, not from this. So coming from this, the final product will be R bond O bond C double bond O bond CH2 bond C double bond O bond CH3 plus here RO minus 3. So this is what your nucleophile, and this is your beta keto ester. So this is how the Claisen condensation reactions takes place. I hope the mechanism is clear. For any doubt, you can ask me directly over WhatsApp. My WhatsApp number is not mine, but it is for free helpline for students for academic doubts. The WhatsApp number for the query is 9680887559. WhatsApp me all your problems. I will try to solve them at my best. Thank you for watching the video. Kailasha Foundation, happy to help.